Let's continue our lecture of chapter R5 of our textbook, part 4, multiplication with whole numbers and areas. Now we're almost done with this chapter. So properties of multiplication. There are certain things that we can do with multiplication and they always hold true. That's what a property is. So the first one is multiplication property of 0. If A represents any number, then A times 0 equals 0. And 0 times A equals 0. That's just the fact. Even if A is 0, 0 times 0 is 0. So multiplication by 0 always results in 0. So let's do our second property, multiplication property of 1. If A represents any number, then A times 1 equals A, and 1 times A equals A. So multiplying by any number by 1 leaves that number unchanged. Third one, commutative property of multiplication. Now if you remember back, we had a commutative property of addition. What did that mean? That meant that if we changed the order of addition, it didn't change the result. So A plus B equals B plus A. Likewise, with multiplication, if A and B are any two numbers, then AB equals BA. The order of the numbers in a product does not affect the result. The fourth property of multiplication is associative property. Remember how we had the associative property of addition, where if we grouped it a certain way, the quantity A plus B then plus C equals A plus the quantity B plus C. Same idea, but with multiplication. So if A, B, and C represent any three numbers, then the quantity AB times C equals A times the quantity B times C. So the grouping of the numbers in the product does not affect the results. So think about those properties. See if you can run through each of these examples and name the property that it looks like. I'll let you pause the video and try it yourself, and then come back to the video for the answers. So the first one is 2 times 7, then times 9, equals 2 times the quantity 7 and 9. Well, that's pretty easy because it's right there up on our screen, the associative property. It's how we group it. Likewise, with 3 times the quantity 8 times 2, and first doing 3 times 8, then multiplying by 2. Again, that's the associative property. We're grouping them a certain way. What about 3 times 2 equals 3 times 2 equals 2 times 3. Oh, well that's just changing the order. That would mean if we're changing the order, we're commuting, we're exchanging. So it's the commutative property of multiplication. Likewise, with 4 times 2 times 5 would equal 5 times 4 times 2. Again, doesn't matter, the order is commutative property. And let's look at 3 times the quantity 2 plus 1, and 3 times 2 equals 3 times 1. Do you remember what that property was? I didn't list it on the 4 that I just chatted about, but that's the distributive property of multiplication. We can distribute the multiplication over the addition. 3 times 0 equals 0. That's the multiplication property of 0. And 4 times 1 equals 4. That's a multiplication property of 1. All of this is chatting about properties and setting us up, is getting us to the point where we can start solving equations. What I mean by is if n represents a number, then the equation 4 times n equals 12. We got to figure out what the n is. So we can read it as 4 times n is 12. The product of 4 and n is 12. What number, when multiplied by 4, gives us 12? Now, you might not know off the top of your head, so sometimes it's easier off to the side to build like a table. 4 times 1 is 4. That's if n was a 1. 4 times 2 is 8. N would be 2, but that didn't answer our question. So 4 times 3 equals 12. N must be 3. Now you might have been able to just figure it out on your own, saying, oh, I know 4 times 3 is 12, but sometimes writing it down in a table is very useful, especially when we're dealing with larger numbers. Now let's look at another example. 6n equals 24. Now I might not know my 6 times tables very well, so off to the side I'm just going to say 6 times 1 equals 6, 6 times 2 equals 12. I might even carry it down to 5. 6 times 5 equals 30. But I'm looking for 6 times something equals 24. And it looks like 6 times 4 equals 24. Therefore, n must equal 4. Now later on we will have a process on how to solve these, but right now we're just going to think about that logically, write out some numbers off to the side and see what our solution is going to be. So let's try another one. 4n equals 36. Now again, I'm going to write down my 4's times tables. 4 times 1, 2, 3, 4, 5, 6, 7, 8. Ooh, it looks like 4 times 9 equals 36. Now, I may have even had to go above 9, but it looks like 9 is my solution to this problem. Let's try another one. 15 equals 3n. 3 times what will give us 15? Again, if you need to write it off to the side, you can do your times tables. 3 times 1, 3 times 2, 3 times 3, 3 times 4. It looks like 3 times 5 is 15. So n must equal 5. And lastly, I showed the answer, but let's say 3 times n equals 21. Again, we can write out what the 3's are, and I just continued it from the table above. 3 times 6, 3 times 7, 3 times 8, and we're looking for 21, so n must be 7. Now that's it for this lecture and this chapter of our textbook. So you should be well versed in multiplication with whole numbers and finding the areas and different types of properties of multiplication. All right, until later, be seeing you.